Well, the binomials are back. So we're multiplying fractions, and now we have various factors that can cancel against each other. Let's take advantage of the canceling right away, because it's so nice to thin out these expressions. Here we have x plus 1 over x plus 1, so we can cancel the both of those. We have x plus 3 over x plus 3, also good. And now with that done, when we multiply this, we have 1 times 2 is 2 for our numerator. And downstairs we have x minus 2 and x. I'm going to switch the order of those just to make it look a little nicer. And that's probably where I would stop. You could absolutely multiply this denominator together and get 2 over x squared minus 2x. I generally prefer to leave these factored, but either one is probably acceptable. Now, restrictions. Remember, you can't use a version like this to do your restrictions. You need one where nothing has been canceled yet. So we actually have to go back to the very beginning here to do our restrictions. And we get one restriction from each of these factors. So we get x minus 2 must never equal 0, which means x can't be 2. From here, from x plus 3, we get x must never equal negative 3. The x is an easy one. That gives us x must never equal 0. You can't solve this. It's solved already. And you get x plus 1 must never equal 0. Therefore, x must never be negative 1. So, 4 non-permissible values. Now over here, this one is not factored. Is that a big deal? Well, it might be. I'm going to pull out common factors wherever I can, and then we'll take a fresh look at this and see if we can reduce it at all. Because at the moment, it looks hopeless. There is nothing that can be reduced. If we take a 4 out of this top left binomial, we get 4x plus 4. Interesting. That'll cancel against the bottom right.
Yeah, I know.
Bottom left, we have, these are both divisible by 7, which leaves us with 2x minus 1. And then we have a 2x minus 1. And in the bottom right, we have x plus 4, and it occurs twice. So, that paid off beautifully. You can tell they cooked this problem to reward us for factoring. We can cancel this x plus 4, and we can cancel one of the x plus 4s down here. There aren't two anymore, there's just one left. We can cancel 2x minus 1 against 2x minus 1. And now this looks a lot better. The finished version will be 4. There's no other survivors in the numerator. And downstairs we have 7 and x plus 4. That's our simplified version. Now restrictions. I'm going to use the factored version I had down here, and I'm just going to try to ignore the things that have been canceled out, because we have to use a version where nothing's been canceled. 7 can't equal 0, don't worry about it. We're going to get 2x minus 1 cannot equal 0. That means 2x can't be 1, which means x can't be 1/2. There's one number we must avoid. And then we get x plus 4 cannot equal 0. I know it was squared. It doesn't matter. It's the same factor twice, and there's no point solving it twice. Just take the x plus 4 and solve that. X can never equal negative 4. So, two non-permissible values, and 4 over 7x plus 4, bracketed obviously, is our simplified form.